All right, our third speaker today is Dr. Robert Barr, Director of Electric Power Consulting Pty Ltd. He's the immediate past National President of the Electric Energy Society of Australia and has over 47 years' experience in the field of power systems and electricity distribution. Robert was awarded the Member of the Order of Australia in 2013 for significant service to engineering, particularly electrical energy supply and distribution. I guess you know a fair bit about grids and systems, right? Not like the young engineers of today. Today, Robert will be talking about the pricing and provision of electricity within Ontario, the selection process by Ontario Power Generation for deployment of an SMR at Darlington, and integration of nuclear energy into the Australian national energy market. Let's welcome Robert to the stage.
Okay. Thank you, Joe, for that introduction, and thanks for the Australian Nuclear Association for the invitation to speak here tonight. I'm going to give you a humble power system engineer's view of the world, not necessarily a nuclear view, and so I'm tagging along with this, the four of us as the token power engineer. So this is I'm coming at things from probably a slightly different angle to the others. So I'm particularly interested in providing low-cost, reliable electricity to customers. I've spent 40-something years doing that, and I'm absolutely distressed at what I see at the moment. We're paying at least 30% more, or maybe even 50% more for electricity than we should be, and things are not looking any better. The government promised $275 a year reduction, didn't they, David, and it just doesn't seem to have materialised at all. In fact, it's gone the other way, maybe even extra $300, $400, $500 a year extra. So I presume they'll go give it to us later on. So let's have a look at what electricity costs. There are surveys that are done around the world, and this survey goes back to March 2021. And if I look at Australia, we're sitting here at around 30 cents. I suspect at the moment it's possibly more like 30, 35 cents. And Rob, I think you were telling me that your bill was up around 40 cents a kilowatt hour. So that's the Australian benchmark. Now, if we go and look at some other countries, we find some very interesting things. Is that there's Australia sitting there at 30 cents. If we go down the bottom, the most expensive power in the survey is Germany. And what do we know about Germany? Yeah, a lot of wind, a lot of renewables. And I think there's a certain correlation between high costs and renewables. Not the renewables themselves, it's all the supporting infrastructure that's required, the transmission, the storage, and all the other parts. And then if we go and look at some of the other interesting countries, like Canada, which we're talking about Canada here. Canada, they're running at about 15 cents on a domestic scale. So at this particular time, they're paying about half what we're paying here in Australia. Right next to them is South Korea, strong nuclear country, around the 15 cent mark, and the United States, where there's a mixture of all sorts of generation, including nuclear at 33% down. So that gives you a little bit of a flavour of where we're at and what we could possibly do. If we look at the low voltage business, these are small businesses, 1 million kilowatt hours per annum. This is like a large customer that would have a substation on site, something a little bit bigger than the corner shop. But they're paying about the Canadians are paying about 34% less than we do in Australia. So no matter how you look at it, the Canadians are doing well. So why are they doing well? Let's have a look at on the Ontario electricity market. I want to talk a little bit about the Independent Electricity System Operator, the IESO. In Australia, we have AEMO, and in Ontario, they have the IESO. It's slightly different. We've got the AEMC, the Australian Energy Market Corporation. We've also got the Australian Energy Regulator, the AER. The IESO encompasses probably all of what AEMO do and some parts of what those other organisations do. And this is just a snapshot that I took the other day. This is Friday the 14th of October. The demand on their system is 14 gigawatts, so you can see that it's quite a substantial system. Not as big as the NEM, but probably bigger than maybe the size of New South Wales and Victoria together. And look at their supply mix. How would you like to have a system where you're providing 6 gigawatts of nuclear power into that? That's what they had at that particular point in time. 4 gigawatts of hydro, 1.8 gigawatts of gas. They've got some wind, 1.7 gigawatts, and that's how they're supplying that demand at that particular point in time. The price, 6.39 cents per kilowatt hour. That's pretty good going. That's just an instantaneous price, but the average weighted price for the month of October was 4.84 cents a kilowatt hour, or $40 a megawatt hour.
That's pool price, Robert?
That's pool price, not delivered price to customers. That's the price in the pool.
Sorry, Rob, that's like wholesale.
Wholesale, that's a wholesale price. But by comparison, you've been looking recently, was it $150?
We're currently for the last 2 months have been 110 to 130.
Yes, yes. And we had a period there where it was very unstable, up around the 300 and 400.
Around the 300.
Yeah. And of course, their system is stable. Our system is unstable. Pricing, we've had our degree of problems, which reflect through in higher pricing. So we go to the Pickering Nuclear Power Station, and I just thought I'd throw these in. These are the CANDO reactors, and the site that David showed us for the small modular reactor is in this area over here. So, and this is Lake Ontario. Sorry, Darlington. Oh, sorry, Darlington, I should say, not Pickering. I apologise. And I should.
That's Darlington.
Yeah, that's Darlington, yes. And the site is over here. So it was great to go on site, have a look around, and see what the Canadians are up to. So let's talk a little bit about the Ontario Independent Electricity System Operator. Their vision for the future is probably similar to a lot of operators around the world, would be energy, and this is no different in Australia. These are the unbundled services that any organisation needs to look at. The supply of energy, that's megawatt hours, the supply of capacity, and capacity being megawatts at the time of system peak and at other times, ancillary services, this is frequency control and the like, flexibility, demand response, being able to move load from one part of the time period to another period of time, and the environmental attributes. So these are the issues that they have to deal with in their system, and they're the same issues that we have to deal with in Australia. Now let's go and have a look at our system. This is running my model, and what we have here is each of these divisions represents a day, and the black line represents our load that's going up and down. Down at 3 o'clock in the morning it's low, and then it's coming up in the morning. And this is the mix of generation that can supply that. Brown coal, black coal, open cycle gas, we've got some hydro, we've got some we've got solar PV, grid solar PV, and we've got rooftop solar PV. And we've got a system that runs along quite nicely. Now, this is the issue I want to put to you, is as the system changes, you get changes in load, and if I go forward, what we have to do is deal with it. We forecast forward and we say, okay, that's going to be the new load that we have to meet. What is the best increment in capacity, generation capacity, to meet that new requirement? And this is where the markets come in. Now we have an energy-only market, and so what we're looking for is the energy-only market to give us signals that would provide that extra capacity in the most economic way. Now, with an energy-only market, what chance does it have to say we should have an increment of brown coal, we should have an increment of black coal, we should have an increment of hydro, we should have more solar? This is the job of a market, is to create the most optimum balance to achieve those ends. And my view is that with an energy-only market and the system we've got at the moment, there's absolutely no chance of getting the most efficient mix going forward. It's just it's just basically impossible. And it's also compromised by the subsidies that are sitting here, particularly on the renewables, that distort even the energy-only market. And the other complexity is that a power station operator looking at this has to not only look at what the market's going to be this year and next year, they've got to look at what that market's going to look like in 2030, 2035, 2040, and just imagine how difficult that would be to do. So let's have a little look at what they do in Canada. The IESO, they go through a power system needs analysis. What they do is they do what AEMO do here in Australia. They'll look at forecasting going forward, and instead of just leaving it to the market or our generator's interpretation of what the market's going to be, they will come up with some plans of what they want to do. Probably no different to what the integrated system plan is. And then once they work out that need, that the analysis leads to a need, they then go to the market in Canada looking for solutions. So if you come up with a gap that's required to be filled, they will go to the market and they'll get a gas option, they'll get a nuclear option, they'll get a solar renewable option, they'll get some battery options, they'll get all sorts of options to go forward. And then they go through the process of selecting what is the most optimum. And to go through that process, they use these. If we looked at the nuclear option that they ended up going with, you look at what will it do to energy pricing? What capacity will it provide? What need or what ancillary services will it provide, or what ancillary services will it need? Will it add to the flexibility of the system, and what are the environmental outcomes? This is something that's very difficult for an energy-only market to do. Humans can do it, because there's engineering judgment involved, commercial judgments involved, but that's what they do. And after going through that particular process, the IESO then selected the bid from OPG, with the OPG bid being the small modular reactor type bid. And then OPG went through an exhaustive process of selecting which one to go with the small modular reactor providers. David showed you a list of all the different companies that are offering small modular reactors. They go through that list, that exhaustive list. They narrowed it down to 3, and then they really bored into those 3 with the commercial analysis. They even got to the point of putting their own engineers into the factories and the head offices of these organisations that were building these, so they knew everything about those small modular reactors. And that's when they came through with the BWRX 300. So I find this a little bit scary. This is my modelling of what we're heading for at the moment. If you look at the integrated system plan, we're heading for something that's almost 100% renewable, and it will look something like this. The black line there represents the load, and you can see that there's vast amounts of solar PV being put into the system, multiple times as the load. A lot of that has to be put into storage. A lot of that has to be transmitted around the country from where it's being generated, from where it will be stored. And and I look at it, can the energy-only NEM deliver what we need? I think it can't. I don't think it is the right structure to create anything sensible out of the way we're moving forward. Will the capacity market assist? There's a lot of talk at the moment about capacity markets, and the Energy Security Board want to introduce one. Well, I'm at the point now, I'm a very strong supporter of capacity markets, but it should have been done back in 2017. Alan Finkel, when he did his report, the opportunity was there to put forward the need for a capacity market, but it was passed over. It wasn't politically popular at the time. And now we're at a point, that was 2017, we're now 5 years down the track. It's almost too late. It's the thing has moved forward to a point where everything's basically very difficult and very uneconomic it's very difficult to get the signals out there to get the mix of generation that we need. What would a nuclear system look like? Well, Rob Parker and I have modelled this one, and so there's our load again. Each of those divisions represents a day, our load. It's a nuclear system wouldn't be 100% nuclear. It's the objective with all these things is to get the correct balance of generation to make these systems work. So there's our nuclear down the bottom. There's good use of solar PV in the middle of the day when these peaks occur, and we can make good use of storage, and we can build a system that can run through there quite nicely with a mix. If we were to build that system, we could get the emissions down to about 22 grams of carbon dioxide equivalent per kilowatt hour, very low level. We'd build a small, compact, minimalist system. The grid would be minimised, the cost would be minimised, because we don't have to go out to Dubbo, we don't have to go out to Armidale to bring these renewable resources back into the system. So what are my conclusions? Australian energy costs are high and are likely to increase significantly in the short, medium and long term. I can't see anything other than prices going up. I don't know how Chris Bowen's going to deliver his $275 a year cut. I'm looking forward to see how he might do it. Customer expectations can't be met with 100% renewables. We're facing what I think is a renewable bubble. The structure of the national electricity market is no longer fit for purpose. The energy-only market has passed its use-by date. It was good at the beginning when we had a whole lot of coal plants, and it caused good competition between similar type plants. It made those coal plants very efficient, but we've moved past that now, and with solar and wind and all the other and the energy storage in pumped hydro and batteries, I think it's past its use-by date. We need to closely study what how the Canadians operate their power system and how they source their new generation capacity. If net zero is the goal, then nuclear appears to be the only viable option. We can learn a great deal from the Canadians. There's one other point that I've missed, and that is when they went through the process of selecting the SMR, the BWRX 300 for Ontario, part of that process was that it ends up on the regulatory asset base, the regulated asset base. And this is particularly important. Many of you will know that in transmission and distribution, the funding for transmission companies and distribution companies come from the regulated asset base. So they generally, that asset base is valued and they'll get something like a 6% return on that. So what Ontario have done, they've taken the model that is used for transmission and now using it for some types of generation. Thank you.